Alright, what's up guys? In this video, I'm going to pick up with some multivariable calculus, and we're going to evaluate a multivariable limit. So we have this multivariable limit. We have the limit x comma y approaches 1 comma negative 2. We got y squared plus 2xy all divided by y plus 2x. So just a couple things about multivariable limits. The same techniques that you use to evaluate or to compute a single variable limits, you can pretty much use the same techniques for multivariable limits. There are a few things though. Remember, for multivariable limits, if you end up getting some indeterminate form, 0 over 0 or something like that, there's 7 types of indeterminate forms, but some of the more common ones that you guys have probably seen are 0 over 0, infinity over infinity. Remember, for Calc 1, if you get one of those indeterminate forms, you could always use L'Hopital's rule in some cases. L'Hopital's rule only works with single variable limits. You can't use it for multivariable limits, so L'Hopital's rule is out. So that's the first thing you need to remember. And then there's also another way that you can deal with some multivariable limits by doing what's called a two-pass approach, which I'll post another video on that instead of talking about it in this video. Now, this is a pretty easy multivariable limit, but they won't always be this easy. So again, we'll use the same techniques that we have used before on single variable limits here. So you start asking yourself, what are some of the techniques that we've learned? Well, actually, the first thing is that you want to do really for any limit is just plug the value in, see what you get out. A lot of people say, well, you can't do it. Yeah, you can. When you plug it in, you see what you get out. Now, that doesn't mean that what you get out will be an acceptable answer, but that's the first thing you should be doing, is you should just be plugging it in, seeing what you get out, because sometimes you might get lucky. If I get out a finite value, I'm done. All I have to do is just sub it in there. If I get something finite out, I'm done. That's it. That's the limit. All limits don't work like that, but sometimes you get lucky and you plug it in and you get something finite out, and that's it. So plug it in, see what you get, see if you get lucky, and then if not, if you end up getting 0 over 0, infinity over infinity, whatever you may get, then you apply other techniques to it. So what are some of the techniques that we know we can use for limits? Again, we know we can't use L'Hopital's rule for multivariable limits, so that's out. But what are some of the techniques that we know about? So we're going to use the same here for our multivariable limit. So we know that sometimes we can factor out things. Sometimes if you factor stuff out, it might make it easier to simplify, might make it easier to evaluate the limit, easier to cancel things out if you end up factoring some stuff out. Again, this is a very easy limit, but I'm just kind of running through all the techniques that you could possibly use. Sometimes trig identities can be used. This is obviously not a trig limit, so trig identity won't be used for this, but you can use trig identity sometimes with some single variable limits. Remember that you could rationalize either the numerator or the denominator by multiplying by the conjugate. That's also something that you could do with single variable limits. And rationalization, again, just multiplying by the conjugate. You typically do that when you see square roots. We don't have any of that in here. And expanding things out and distributing, multiplying things through, whatever. So these are just all the techniques that we use for single variable limits. So with the exception of L'Hopital's rule, we can use all of these same techniques to evaluate this limit. Now notice here, if we plug in 1 and we plug in negative 2, remember this 1 corresponds to x, this y, negative 2 corresponds to y. Notice that if we sub it in here, we'll get 0 over 0. So clearly substituting in x is equal to 1 and y is equal to negative 2 is not going to evaluate this limit. So we have to do something else. The good news is, if you look up here at the top, we got y squared plus 2xy. Well, if we factor out a y from the top here, or from my numerator, we'll just have y multiplied by y plus 2x. Notice down here at the bottom, I have y plus 2x. So what's going to end up happening is the y plus 2x's will cancel out. You can always check to see whether you factor something correctly by distributing it back in. So let's factor the numerator. So I'm going to factor out a y. So we got y squared plus 2xy. If I factor out a y, I'll get y multiplied by y plus 2x. Now, distribute it back in, see if you get that back out. Well, if we distribute the y back in, we do in fact get y squared plus 2xy. So we know that we factored it correctly if we take a y out. So now this limit becomes the limit x comma y goes to 1 comma negative 2. And then it just becomes y times y plus 2x, all divided by y plus 2x. So now the y plus 2x's cancel out. Now I'm just left with the limit x comma y approaching 1 comma negative 2. And I'm just left with that y. So all I have to do is stick the negative 2 in. And if I stick the negative 2 in, I'll get negative 2. So the limit here is negative 2. And that's the final answer. So that's a multivariable limit. So they won't always be that easy, but this is just a general example. And even though the number is negative here, it is still finite. Keep in mind, a negative number is still finite. It's just negative, right? So you can have a negative number for a limit, and the limit exists, just negative. So our final answer here in our limit, which we'll just denote L, is negative 2. That's the answer. So try some of these. There's plenty of them in your calc textbook. In my calc textbook, I have this one. Maybe you got a different one. Let me show you just very briefly. Calc textbook that I have. So when I graduated, I got my physics degree. I actually went ahead and just bought the calc textbook. And there's so many examples in here. And if you want to go to the section, it's going to be functions of several variables. And you might have a different textbook, and you don't learn about multivariable limits until Calc 3. So you'll need to go a little bit farther in the book. I'm not sure where it's at. You can certainly get some of this stuff offline as well, some practice samples. You don't have to. Shoot, can't find it. Somewhere around here. Probably should use the table of contents, right? Probably so. Oh, here we are. Oh, remember the 2-path test I was talking about, the 2-path approach at the beginning? Well, I'll post another video on that. So here we go. For limits with 2 variables, keep in mind limits, multivariable limits can also have 3 variables. So it doesn't just have to be 2. It can be 3. So you could have the limit x comma y comma z approaches this, 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 and this. It doesn't just have to be 2 variables. It can be 3. And as you can see, there's just a whole bunch of examples in here. Here's the page I was looking for. Just a whole bunch of examples in here that you guys can look at. All right, so I just wanted to show you guys that. Get yourself a textbook, practice some of these, give it a try, and see how they work out. All right, so I'll post some more content here shortly. And so I thank y'all for joining the video. And again, I'll get all this posted. I'll post all the solutions by hand as well. So I'll see y'all next time.